Okay, so for everyone here, chemistry, this is the 2014 paper, right? We're going in order. So this is the May June 2014 paper 1 for chemistry unit 2. And it starts off with these questions. All right. Number 1. The combustion analysis of 0.18 grams of an organic compound produces 0.396 grams of carbon dioxide and 0.216 grams of water. The empirical formula of the compound given that it contains carbon, given that it contains carbon, hydrogen, and oxygen only is. So we're looking at that. What was the answer for this?
I think we got A for this one.
Got A for this one.
A.
I personally don't believe in like doing over them. Alright, for the 30. 2. Which of the following compounds show optical activity? 1 and what? 1 and 4?
1 and 4.
1 and 4.
Alright. Volatility of organic compounds depend on the strength of their intermolecular forces present. Which compound below is the most volatile?
A, since it's alcohol.
Sure? The volatility of a compound hold on. Give me a second. Hold on, give me a moment. Everything is slowing. Can you guys see my screen?
Yeah, we can see.
Oh, but I can't see. That's interesting.
It's gone now. Okay, it's back now. Are you referring to the whiteboard or the past paper?
The past paper.
Yeah, we're still seeing the past paper.
Okay, alright, so let me just get this on the way. Alright, so let me not do all of that. So let's just use volatility as V, right? So volatility, we're saying that it has a relationship with intermolecular forces, right? With IMFs, right? So you know IMFs. What type of relationship do we have with IMFs and volatility? Is it directly proportional or inversely proportional? As the intermolecular forces between compounds increases, right? Doesn't that allow the volatility to decrease?
Yeah, so they're inversely proportional.
All right, so it allows that to decrease, right? So we're looking at this now. So that means that the ones which is most volatile is the one with the least amount of intermolecular forces between each other. And the intermolecular forces relate to what? IMF relate to what? Polarity. Right? So the compound has to be polar to have intermolecular forces, not true? Well, I mean, it doesn't have to, but it will have more intermolecular forces and it will be stronger intermolecular forces if it is polar. True or false? Tough crowd. Okay, so we're looking at this though. Well, I'm saying, right, the intermolecular force is directly proportional to polarity, right? Meaning that the more polar a compound is, right, the more interactions or the stronger the intermolecular interactions. That's true, right?
True.
And that means that the more polar substances, the less volatile it is.
Yeah.
Okay, the most polar substances here would be the ones containing oxygen. Oxygen creates dipoles across molecules. We don't want oxygen here, right? And we have two alkanes here, and the branch alkanes tend to be more volatile than the normal straight chain alkanes, right?
Yeah.
Okay, so that is that. So C is the most volatile. All right, so let's move up. So number 4, looking at this, the ideal detector used in gas chromatography, GC, right, has specific characteristics. Which of the following characteristics are for a GC detector?
I know that it's very sensitive. I'm not sure if it's stable. I'm not sure if it's easy to use because I remember my teacher saying something about an expert having to use GC. But I'm not sure if it's the entire like setup of it or if it's just like the detector itself. So um I'm really not sure.
Okay. Anyone else?
But I if I were to put an answer, I would put B.
B, 1 and 3. So does it have to have a short response time?
A.
Okay, I'm seeing that. All right.
I think for this you have retention time instead of retention factor.
Yes, you
So
do have
no.
retention time. Mm-hmm.
Yeah, but that's a A.
All right, so you're saying A. So it has to have good spectral response. So I think that the response time, though, right? The response time specifically, is it a short response time? It needs.
I believe it's a short response.
Okay. All right. So the response time specifically, right? It needs to be a very fast response time, so it has to be short, right? So I believe that 1 to 3 are fine, but we need to verify whether or not it's easy to use.
Well, it would be difficult.
Well, some apparatus requires experts to use, to be very honest, right? So you'd have to develop a skill of using it. So I want to recognize whether or not it's easy for anybody to use. Is it a press of a button, right? Or do you have to set up complex apparatus to set up this gas chromatography? We want to know if that's true. So is it easy to use?
Well, it
I
has
don't think so.
It is based on research.
Based on, I heard based on and then the mute mic, so I don't know what it's saying.
No, I was looking it up. It does say that it's easy to use, but I had to look up how to use it to see.
Okay, could you send that evidence?
well, it look like it have to be D since it's a 1 to 3. Good. So D is the answer.
Because it has to have good stability, as you're saying, right? The response time needs to be quick, so therefore it's gonna be short because rates, like if you relation, whatever, right? Physics. Adequate sensitivity, it has to be really sensitive, but it says adequate, so no must. All detectors have to have adequate sensitivity, right? But whether or not it's easy to use. But I guess if that doesn't mean that D is the answer, We really have to determine whether or not it's easy to use. Because if it's not easy to use, then everything with 4 is out. So could somebody verify that, please? I don't want to put any incorrect answers here. Especially for something from 2014 that can repeat, because if stuff came from like 2012 that repeats it like 2020, 2020 and 2022, then things can repeat from here, I guess.
I don't know, but if my memory serves me correct, I remember my teacher saying that it's a bit complex and you would need like experts to actually use it. Like a regular person like me couldn't just go in the lab and just know like what they're doing.
Okay. So it would
So
be, if you know what to, okay, you know what gas chromatography is all about?
yeah, ish.
All right. So you know how it is, right? Separating and analyzing compounds, right? And you have to vaporize. You have to vaporize it without decomposition and all sorts of stuff. So there's actually, I wanted you guys to find this now, but there are actually, you know, lab specialists, right? Like lab technologists, right? So lab techs, right? Some labs may have regular lab techs, right? And then some will have analytical lab techs, which are specialists, right, in gas chromatography and specialists in thin layer chromatography and all different types of stuff. So you have to have like a lab specialist to work with certain types of instruments, right? For example, a professor can, you know, do all sorts of lectures on chromatography and all those type of things, right? But when they're in the lab, the specialist does it, right? The lecturer would know everything about it, but the specialist does it because specialist is a specialist in it. So I think you require a lab specialist. You need a mass spec specialist and you need a gas chromatography specialist, I believe. So those two instruments probably need specialists to work with. Based on its high sensitivity of the detector, nobody can just come into the lab and do it like that, right? And working with the vaporization of a compound, you have to know the compound and know how to vaporize it without decomposing, right? It's not saying that we're slowly heating it up, you know. We vaporize it completely, right? Without decomposition. So it requires a lot of skill. You hone it over time. 5. Which of the following statements about polyunsaturated oils or triglycerides is false? B, right? Alright. Looking at this now. Which of the following... Alright, hold on. It's loading. So which of
When you
the...
finish, you can just scroll back up, please.
Okay, I'm scrolling back up now. So what's the problem with it?
Following that. All right, thanks.
Yeah, if you hydrolyze a triglyceride specifically, you shouldn't get a diglyceride. So that should be it. So which of the following alcohols will not be oxidized by acidified potassium dichromate?
D.
And that would be a tertiary, right?
Mm-hmm.
Yep. No reaction with Lucas's test or Jones test, right? Wait, I think no man, Lucas's test, right? So number 8. Which of the following statements are correct concerning compound J? Oh my gosh, compound J. Alright, it will decolorize aqueous bromine. Is that true? Will decolorize it, right?
Yeah.
Alkene, wonderful. It will decolorize cold acidified potassium permanganate. Is that true?
Yeah. Mm-hmm.
Right. And it will produce a silver mirror.
No,
No.
that's like, isn't that ketone?
It's a ketone. So 1 and 2 should give us a. Wait, why did I do it across a while ago for questions here? Number 7, in the reaction between ethene and bromine, which statements about the reaction mechanism may be true? Ethene and bromine, so the carbon. Oh, this repeats, right?
That you never the number. Oh,
Yeah, scroll across it. Number 9, the correct sequence of compounds above in order of decreasing strength is what? RQSP, right? Am I mistaken here? R would be the strongest, right? Yeah, R should be the strongest, I believe. And that's why the one with R first would be the answer. 10. Which of the following compounds does not give a white precipitate when shaken with cold ethanoic silver nitrate. Well, ethanolic, sorry, silver nitrate. All right. So what would be here? Which will not?
A.
A. All right. Why A?
I think the position they are more stable. The chlorine atom more stable. So I don't know.
Okay. What's the reaction we're describing here?
But if you like the 2, 4, 6 position is like the most stable, so the chlorine won't really be removed that easily.
Mm-hmm. So we're testing for the silver nitrate. We're testing for halogen alkanes, right? So we're using test for that. So what's the reaction mechanism? Or do you use it? I think I'm not sure if we still do the reaction mechanism for it though. All right. So we're going with A as the answer. Does everybody else agree? If we choose A as the answer, does everybody?
Yeah, I agree.
All right. So going with that. 11. The complete reaction of phenol with aqueous bromine is characterized by
A.
okay. That was the creation of tribromophenol. Give me one moment. I don't want the fan anymore. Thank you. Alright. Which of the following organic compounds would release a proton most readily?
B.
Wonderful. Hope I don't have to, no one has to ask why for that. So item 13 refers to these. Which of the following options has the labels in the correct order to match the structures? Excuse me? Wait, what? I guess it's just a correct order. Alright, so what's happening for this?
A.
So it's gonna be a positive inductive effect, alright. And then we're gonna have negative inductive effect and then conjugative effect. Alright. That should be fine. 21 now. So the structural features which cause absorption in UV spectra are known as
B.
chromophores. And it creates a bathochromic shift, or what we call would be a blue shift, right? Blue shift. Wait, hold on, it would be red shifting, isn't it? No, never mind. I'm gonna have to review that. But it's a bathochromic shift. Okay, 22. Which of the following alkenes has the wavelength maximum, well, of a maximum absorption here? Lambda max. Would be B, right?
Yeah, I would say B.
Alright. 23. Alright, so 23 refers to ethanol. We did this already. Alright, which of the following analytical techniques is considered most specific for identification purposes?
Yeah.
A, wonderful. I did that already as well. Alright, let's see what's happening here. Which of the following compounds, well, pairs of compounds, do not absorb infrared radiation?
Think 2 and 4.
2 and 4. Alright, D. Which of the following media is not a visualizing agent in chromatography?
Cellulose.
cellulose. You sure?
Then hydrogen is used for amino, I think. Iodine starch, UV. Yeah, cellulose. One of them cellulose.
Okay. 27. The RF value of compound A is what? So compound A distance traveled is there. Where's the solvent front? How do you calculate RF value?
Distance traveled by solvent over distance traveled by component or dye.
What's the answer? 2.5.
I think it's the other way around.
Is that the way around? Solvent front divide. Wait, hold on. Oh. I think it would be the other way around for real. Because that should give us, that value should be too large. So it's the other way around. Alright. Okay, so this should be what, 1.5 divided by 12.5. And that should give us what? B, right? Okay. Here now, which of the following mixtures cannot be completely separated by fractional distillation?
D as in dog.
Alright, why?
Azeotrope.
They're both azeotrophs. And it's the boiling point composition curve. So which one is positive deviation?
Positive would be 2. Negative would be 3.
Alright, wonderful. Number 14, sorry. Which of the following statements is not true of addition polymerization? We saw this, right? So it can't be hydrolyzed to create a monomer. The product formed by the polymerization of propene can be used as a plastic material. Which of the following inaccuracies may be eliminated by systematic errors? All right, the concentration, okay, we saw this already. So like these are just all repeats, right? What was the answer for number 17?
I think it was
27 will be on top, right?
C, I think. No, say one with the 2 times. I don't remember which one.
All right, but it has to be divided by 25 because we're finding concentration, therefore it must be divided by the volume, therefore 25. It must be at the bottom, right?
Yeah.
All right, so can use that. Okay, so number 18, this I believe. Please load. The gravimetric analysis of a substance by precipitation, which of the which of the following outcomes would be false for the precipitated form? Well, the precipitate form, the PPT form, which would be false. False. The composition would be unreactive in the atmosphere.
B.
Its composition would not have to be known. Are you saying that we have to know what it is?
Yeah, I think so.
So before we go through gravimetric analysis, we have to know what we're analyzing. So this is true, this is true, this is fine. Okay, so it would not have to be known. All right, so that's fine. A 300 milligram, the answer is C. I'm sorry about that, but like, yeah, we did this already as well. So the answer is C for that. In an electronic transition in the UV visible region of the spectrum, a wavelength of that is absorbed, right? The energy of the corresponding photon in joules would be?
Did this already.
D, all right. So what's the formula?
E is equal to HF. F is equal to Hold on. E equal to HC over wavelength.
You sound unsure when you were saying that. You sure?
You remember F is equal to speed over wavelength, so
Mm-hmm.
they give us the wavelength, so we have to use that formula.
All right. So we have Planck's constant check, speed of light check, wavelength check. So it's fine. So let's look at this now. Which of the following statements about the partition coefficient may be true? Two only, right? We did that already. So that question was coming way back from here, so I've not seen it in a while now.
Hold on, I come back.
Well, hold on.
So the formula of a partition coefficient may be true.
Is it 1 and 2 only?
You sure that temperature doesn't affect it?
It's actually maybe true. They reworded this. Substances. It doesn't not. It doesn't it vary with temperature?
It vary with temperature, yeah. Sorry.
Okay, no, it's not a problem. Alright, so let's down. So we have a simple distillation setup, right? That's simple, I guess. Right, so which of the following processes is the apparatus not suitable for? This would be the conversion of phenylalanine to benzene diazonium chloride. Right, but it should be suitable for everything else because they have different boiling points. Alright. So let's look at 31, right? Which are along with silicon dioxide, which of the following compounds constitute the main impurities of bauxite? It would be iron 3 or iron 2 oxide.
Any iron? Wait. Which one is the red one? I think is A.
Alright. So we have
The iron 3 oxide red?
wait, the iron 3 ion is red. Iron 2 is green.
Let's actually remember the color, come know that give the bauxite the red color.
Okay. The correct order in terms of increasing boiling point here is what? We know that refinery gas is going to be at the top, right? But those are the smallest. Therefore,
Then petrol.
Repeat?
Then petrol.
Then petrol, alright. And then what's the difference now? Is diesel or kerosene?
Then kerosene. Then diesel.
Alright. There it is. The essential conditions for the Haber process, we know it would be high temperature, high pressure, and an iron catalyst, right? That's the essential conditions for it, right? But industry doesn't really deal with the high pressure. It's a bit expensive. 34 refers to the manufacture of chlorine by the electrolysis of brine using diaphragm cell. The anode is made up of titanium with an inert coating of ruthenium 4 oxide. That's 4, right? Yeah, I think so. Alright, so let's look at this now. This is what, 35. For which two of the following industrial products is chlorine most widely used during their manufacture? So we're looking at products of the brine industry or the chloralkali industry.
B.
D. So we're saying 2 and 4.
No, I said B as in boy.
Okay. So you're saying wait, hold on. So you're saying solvents and polyvinyl chloride. Alright.
Oh no,
Alright, go ahead.
I'm thinking sodium chloride now. But like, is that widely used? I'm not sure.
I'll say A.
Okay. So It shouldn't be sodium chloride, wouldn't it? Wait, hold on. It uses chlorine and caustic soda, right? And then it's are produced by simultaneous. It's going to be electrolytic decomposition of sodium chloride, right? The main products of it's going to be decomposed. Sodium chloride will be decomposed, right? So therefore, it produces chlorine, sodium hydroxide, potassium hydroxide, sodium hypochlorite, polyvinyl chloride, and hydrogen chloride. I think so. I don't think sodium chloride would be decomposed within the industry. Therefore, I believe it would be polyvinyl chloride, right? And probably some solvents, because the acids and the bleaches can be used as solvents. You get what I'm saying? If we remember that. So I think it would be 1 and 3. I don't think sodium chloride would be created. It's sodium hydroxide, right? Or potassium hydroxide could be created. And the byproduct would have been like chlorine gas and the sodium hypochlorite, which is bleach. All right. So in the production of sulfuric acid by the contact process, the following reaction is exothermic. If it is exothermic, we know that it has what enthalpy change, positive or negative?
Repeat. I didn't hear.
Does an exothermic reaction have a positive or negative enthalpy change?
Negative.
All right. So the enthalpy change would be negative. Okay, just asking. So we're looking at this. If it is exothermic, what would the temperature have to be for ideal conditions? The temperature would have to be low, right?
Mm-hmm.
And then we know that if we pressure, right, pressure affects the equilibrium in a way where it favors the increase in pressure favors the least amount of moles, right? So over here it's 3 and over here so it's 2, therefore we would need a high pressure, right? And then excess oxygen would probably be needed. So 2 and 3 C. So Le Chatelier's principle. Number 37, compounds of sulfur such as sulfites are used as food additives because they inhibit the oxidation of unsaturated fats. Alright. 30, this is 8. Allow it to load. In which of the following industries is sulfuric acid used in the development of their products? Sulfuric acid is used in the development of fertilizer, paint, right? It's used in the development of some fibers, but I'm not sure which to put there.
As a catalyst for some polymers, probably.
So it would be all. Does anybody? I'm not sure if anybody have anything to dispute with this. I think sulfur can be used in all of them. Which of the following ions are significant contributors to eutrophication?
1 and 2.
1 and 2. And we know this because most of the bacteria and algae would be chematotrophs, right? And chematotrophs feed on phosphates and nitrates and other types of chemicals in order to, metabolize and reproduce. That means when the fertilizers and stuff like that run off into nearby water streams, it increases the concentration of these ions, right? That allows for the algae and bacteria, right, to bloom at a faster rate because it has such excess of chemicals, right? So it starts to reproduce quickly and cause eutrophication. So
Answer 37.
Oh, 37. Yeah, there's 37.
All right, done.
All right. Let's look at this. Aerosol propellants such as Ferron 11, right, are well, for an 11, you know, and then you would have that molecule there, right? What would I say? Trichloro, monofluoro, whatever. Are a major concern because of their photochemical reaction with ozone, right? So ultraviolet radiation in the stratosphere produces chlorine radicals, right? So notice that chlorine radicals. So when we see the chlorofluorocarbon and we're seeing all the chlorine and fluorine together, it is chlorine which should be removed, like creating chlorine radicals, which then react with ozone producing oxygen. A balance equation for the production of oxygen from ozone is it B? What is the answer? This is taking a bit too long. I think you're working with your redox numbers. I'll give you like 5 more seconds. What's it?
Are we doing number 4, you know?
Yeah.
B?
B.
Oh no. Yeah, B.
Alright. Wonderful. If we remember from module 1, literally one of the first reactions we've ever done in our entire lives, right, would have been free radical substitution. And we know that when a radical reacts with a stable species, it creates a radical and a stable species. Therefore, B has to be the answer. 41. The balance equation for the photochemical decomposition of ferron 11 is... So just applying what we did up there. It did tell us already that it produces chlorine radicals. Therefore, I don't want to see anybody with anything else.
C.
C would have to be the better answer. Wonderful. Chlorofluorocarbons undergo homolytic fission by being exposed to UV light in the stratosphere. Which of the following radicals could be a result of that? A, right?
Yeah, hey.
Wonderful, thank you. Now let's load up. Which of the following compounds is not a primary pollutant? Nitrogen dioxide. Which of the following resources are normally associated with the formation of photochemical smog? Would be all of them? Or would be 2 and 3?
All of them.
Alright. So it'd be all of them. This is repeated as well, I believe. 45. Which of the following plastics is biodegradable?
C.
Okay, I'm seeing C. Ooh. Polyhydroxylbutanoic acid. Why? Why C?
Probably because the acid can break down.
So we know that there are mainly 2 types of biodegradable plastics, right? There are polyhydroxyl alkanoates, PHAs, and polylactic acids, which are PLAs, right? Mostly. Those are usually like the most common types of biodegradable plastics, right? And they're usually acidic in nature, right? Or they're esters. So I think C would be the best answer. So we have those. I think it would be a PHA to some, well, it wouldn't be a PHA per se, but it would be acidic, right? So, so that should be fine. Alright, so that would be the end there of 2014 Unit 2's Paper 1. Alright, that should be fine. Are there any questions though relating to this paper?